Hey, good morning, everybody. It's Wednesday. I just looked at your results from yesterday, and I noticed two things. One, we're not really ready for a factoring test yet. I got my notes here, and first, I'm noticing a lot of missed. Get more sorry, my dog just walked in. Hey, Perry. Here, I'll show you my dog. Hey, that's Perry. No, okay. All right, hi, buddy. How you doing? Okay. All right. So I noticed that a lot of GCFs are getting missed. They're just not getting taken out. So I'm going to show you how to do that in just a minute. The second thing that's happening is a lot of people are still taking out negative leading coefficients. I'm going to show you examples of both of those things so we can try to work around them. Tuesday's class was lengthy. There was a lot of stuff. You guys did a great job of getting through it all. Today we're going to try to keep it lighter. I'm going to push the assessment back one day. So let's go ahead and improve skills today. We'll practice on Tuesday and maybe we'll test it next Friday. So let's go ahead and figure out those two things. So first, let's talk about GCFs that are getting missed. In the first example, when I look at the first binomial, I still have a common factor of 2. This is 2 times 2p minus 7. Like that's more factored than the 4p minus 14. And then you could probably imagine the second binomial is going to exactly have the same thing. So it's still a 2, and it's 2p minus 7. What you'll notice is the stuff inside parentheses has no more common factors, no more numeric or variable factors. This last piece was a-okay, so p minus 4 was fine. And then here's how we'd finish this off. The constants that are removed or factored out, the 2 and the 2, 2 times 2 is 4, and then we literally just write everything else. Now I am going to cheat a little bit. I've got 2p minus 7 and another 2p minus 7, so I'm going to write 2p minus 7 quantity squared, because that's what it means when you have 2p minus 7 times 2p minus 7. And then the p minus 4, we don't want to forget about over here, so there we go. This is the answer. The one below, it's a little bit more common. It's been factored correctly. We find ourselves with one binomial that is completely factored. There's no common numbers between the 10 and the 7. The only common factor is 1, and we're not really going to worry about that one. And there's no variables in common. There's not a y in both of these things. However, over here, there's a couple of things. First, there's a common 6. These both have a factor of 6. This is 6 times 1. This is 6 times 5. And they both have a factor of y also. This one is y times y. This is just y times 1, I suppose. So y is a common factor. Now, if I think about removing the 6 and the y from 6y squared, I have a single y left over, because 6y times y is 6y squared. The minus sign is going to come down, and 6 times blank is 30, so there's a 5, and y times blank is y. Well, we don't need anything there, so that's more factored. I'll bring the 10y squared minus 7 down, and then I'm done. So here's an example I just made up off to the side in between yelling at my other dog. She likes to bark at everything. So she might bark in the rest of this video, but let's check this out. So when I look at this guy, first off, I notice it's a trinomial. I also recognize that the 15, the 10, and the 105 have something in common. They look like they're going to have a 5 in common, because 5 times 3, 5 times 2, and 5 times 21, I think, is what we got there. So I'm going to go ahead and remove a 5, which, if you're not sure how this works, think about it like dividing each one by 5. That would be a way to think of this. Now, the other piece that you would consider is the variables. I've got x's and y's. I have x to the third, x to the second, and x to the first, essentially, so they each have at least one x. So I'm going to also think about x as a GCF, and y, they all have a y in common. So y is part of the GCF as well. So what I'm doing is actually dividing by the GCF. Now what that'll mean is I'm going to put the GCF in the front, and then I'm going to make myself, just like I started with the trinomial, I'm going to make myself a trinomial here, but it's going to remultiply to give me this blue original statement.
So 5 times what is 15, so it's 3. X times what is x to the third, so x to the second. And y times blank is y, so we don't need anything there. You can see the rest. 5 times blank is 10. X times blank is x squared, and y we don't need. And minus 5 times we said 21. X and y are both represented, so there we go.
Now this might be done if this doesn't factor. At this point, I'm going to go ahead and do the factoring piece here and see if it works. I'll fast forward on the video. And there we have it. I will point out that we should always be double checking. You should always be double checking. The double check for me is
I do a quick multiplication. X times 3x is 3x squared. And I kind of do a mental math of 3x squared and 5xy is 15x cubed. So we know the first part is right. The second term, I'll do the rainbows. I'll do the outsides and the insides. So x times negative 7 and 3 times 3x. So this is negative 7x and positive 9x. So that's positive 2x. 2x times 5 is 10. X times x is x squared and y. So we have that part. That part's good. And 3 and minus 7 is minus 21. Minus 21 times 5 is minus 105. Xy is xy. So we know we did it right because this is the double check.
So that's a way from start to finish on how to factor out a GCF. It's not a grouping problem, but the GCF is the problem that seems to be cropping up on us, not the grouping. Now, second thing that comes up is that negative leading coefficient. So let's check that one out. Okay, here's an example that jumps out at me when I'm looking at this thing about the negative leading coefficient. What I mean by that is this negative sign here and this negative sign here, I'm using red because these things are bad. You don't want these. And when you see them, it should set off alarm bells of things that you want to avoid. The good news is you can avoid them really, really easily by just using some factoring. So check it out. I'm going to write this problem out with some space. There's my 6y. I'm going to go ahead and write negative y plus 5, and I'm going to write negative 10y squared plus 7. I would not normally do this in, let's say, a homework assignment, but I want some space in the video. This piece right here, I use lots of colors here. This piece right here, I'm going to factor out a negative 1. I'm going to factor out negative 1 because of that negative sign, right? I don't want it there, so I'm going to factor it out. And negative 1 times what is negative y? Y. And negative 1 times what is positive 5? So I got to turn a negative with multiplication into positive, so I need a negative on there, right? See how that works? I'm going to do the same thing here. I see the negative leading coefficient, so I'm going to factor out immediately a negative 1, and you might already see that all we're really doing is switching these to their opposite. So negative 10y squared becomes positive 10y squared, and plus 7 becomes minus 7. That's it. Now, we never did change the 6y, so it's still sitting out here, and let's make sure that you know that this isn't minus 1, it's times negative 1. And watch how cool this is. The 6y is still just 6y. The negative 1 times negative 1 is positive 1, which for all intents and purposes means it cancels out. Now, if you would have just one leading negative coefficient, then that negative would come out here, but we don't have that, and I've not really seen that pop up too much. So at this point, then, all we're going to do is finish it off. Y minus 5 and 10y squared minus 7. And that's how you deal with those negative leading coefficients. So really, look for those negative signs in front. If you see them, work on getting rid of them so that you can be more successful. So today, let's go ahead and try to wrap up factoring. Let's do a lot of checking. I'd love to chat with some of you on Zoom if you find that you need it. And let's get through this, all right? Good luck.